Hey guys, it's Mr. Harper. So you should have taken your second quiz yesterday, and again, the best one of those will be the second part of your test portion. And so we're going to be starting something new on Wednesday, and so I'm going to go ahead and kind of go over some problems. And what I've done here is the ones that I'm going to work out are in red. The ones I want you to do or work out yourself are in green. And so I'm going to do the red ones. You're going to do the green ones. Now, what we're going to be doing first is solving exponential equations. And what makes this exponential, so you may notice it has the word exponent in it. So what makes it exponential is that the x is in the exponent. So this is 2 to the x plus 6 power. So because the x is in the exponent position, that makes it an exponential equation. So, and what you'll notice, these are actually some of the easier ones. I'm not going to say they're easy, but they're the easier of the ones we're going to do. What you'll notice in example 1 is that the base, in this case the base is 2, is the same. Whenever the base is the same, you're just going to take the exponents. So in this case, the exponent is x plus 6 and 5, and you're going to set them equal to each other. So you would say x plus 6 equals 5. And then you would just solve that equation. So subtract 6, and you get x equals -1. And that's it for that one. So, and again, I want you to work out example 2 yourself. So let's look at example 3. So again, let me just restate. Because the bases were the same, we were able just to set the exponents equal to each other. So the same thing is going to be true in example 3. So notice the base here is 4. So I'm just going to take the exponents, which is 2x and x plus 1, and set them equal to each other. And then solve this equation. Now, anytime you have an x on both sides of the equal sign, you need to move one of those x's. So I'm actually going to move this by subtracting x. Now 2x minus 1x is 1x, or just x. So in this case, x equals, the 1 comes down, and so x equals 1. You can't say 1x equals 1, but that's the same thing. Okay, so again, when the bases are the same, you just set the exponents equal to each other and then solve that equation. And so I want you to do example 4 and example 2. So now I'm going to do a couple problems on the next page. Now what you'll notice, so again, I'm going to do 7 and 9. I want you to do 8 and 10. What you'll notice is the bases are not the same. So what we have to do is we have to make them the same. So what I want you to think when you're looking at problems like this is, what can I rewrite 9 as, or 27, that have the same base? And so, for instance, in this case, 9 is the same thing as 3 squared. So I'm going to write 3 squared to the power of 2x minus 5. So I thought, well, 9 is the same thing as 3 squared. And 27 is the same thing as 3 to the third power. So it's going to be, I'm not going to say hard, but if you don't know your powers, so looking at 27, I naturally know that's 3 to the third power. That may not come as natural to you. But because you know 9 is 3 to the second power, you could think, well, maybe 27 is 3 to some power. And so you're going to have to kind of play around with that. So the first thing you have to do when the bases are not the same is make them the same. And so you have to ask yourself, 9 is what number to some power? So like over here in the green one that you're going to work out, I could rewrite 25 as 5 to the second power. And that's actually what you would want to do for this one. 5 is already there, so you don't even have to do anything with that one. But because 25 is not the same as 5, we have to make it the same. And we do that by finding a common base. So here, we're still not finished here. So notice I rewrote 9 to the 2x minus 5 power as 3 squared, because 3 squared is 9, to the 2x minus 5 power. Now, when you have something that looks like this, so a power to a power, you need to multiply the 2 times the 2x minus 5. So you need to multiply the 2 by both of those. So it'd be 3 to the 4x minus 10. So notice that 2 multiplied by both the 2x and the 5 equals 3 to the third power. And now what you'll notice is we do have the same base. So here my base is 3 and here my base is 3. So now I'm actually able to do what I did on the other one, which was set the exponents equal. So I'm going to take that and set it equal to that. So 4x minus 10 equals 3. And then I solve that equation. So I would add 10 to both sides. And get 4x equals 13. Oops, 13. And then divide by 4. So then your x would be 13 over 4. So it is possible to get fractions. So again, the first thing you want to do if they don't have the same base is you want to make them have the same base. And that's going to be hard sometimes. You have to be able to, you may have to play around in a calculator to get that. Now looking at number 9, let's see how much time we got here. Okay, so looking at number 9, we have 16 and 64. So then the question is what could the common base be? Now in this instance, there's actually more than one answer. I could think of 16 as 4 squared, which I'm actually going to do that. 4 squared. So 16 is 4 squared to the negative x power. And then 64, you may not know this, is 4 to the third power. And so you may begin to see how we're going to have the common base of 4. Again, when you have a power to a power, you multiply. So negative 2x equals 4 to the third. And now that we have the same base of 4, we just set the exponents equal to each other. And I'm not going to do that for the sake of time, but I would set negative 2x equal to 3 and then solve for x. But this video is already getting kind of long. So I want you to work out the 8 and 10 as well as the 2 and 4 on this worksheet. And please, please, please feel free to ask me any specific questions you have. And I hope you guys are staying safe.